Okay, so the biggest thing that we need to remember is that if you have log of a number, that number has to be greater than 0. So we're going to solve this exponential inequality. We're going to solve it just like we were solving the regular equations. You got to get x by itself. Right now it says 3 to the x is less than 20. How can we get x by itself? We need to get rid of the 3. How can we do that?
Log 3.
We're going to do log base 3. You're going to do it to both sides. So we're going to do log base 3 of 3 to the x less than log base 3 of 20. So log base 3 and base 3 cancel out, so we get x. So we have that x is less than log base 3 of 20. And at that point, x is by itself, so how do we find the approximate number of log base 3 of 20? Right, we're going to use the change of base formula that we learned a few days ago. We're going to do log 20, and everybody has their calculator out? Of course you do. Do it. Make sure you get the right answer. We will be doing graphing calculator activity later today in our class, so make sure you do have your graph calculator out.
Okay, I tried it.
Did you get it? Did you get it? Brownlee, we are on the back of our notes we did last time. Yep, I'm going to actually do 3 decimal places, but you did it correctly. 2.727. All right, next example. We're going to solve log x less than equal to 2. Now remember, if we have log in it, the one rule you have to remember. If we have log in it, what's that one rule you have to remember? X has to what? Has to be greater than 0. You just have to remember that. Keep that in mind. All right, what are we going to do to both sides to cancel out the log and just get x? Right. What you're going to do is you're going to take the entire side of the equation and put it to the make it the exponent with a base of whatever this base is, which is 10. So you're going to take 10, and the entire side goes to the exponent. And then you have to do the exact same thing on both sides of the equation. 10, and the entire side goes to the exponent. The entire side goes to the exponent. That will cancel out. 10 and log base 10 will cancel. And we will have x less than equal to 100. So, is that my answer? X has to be greater than 0, but if I say x is less than equal to 100, that includes all those negative numbers. So I'm going to phrase it so I'm saying that x is greater than 0 and also less than equal to 100. We write that, remember, when you have to put the x in the middle of the two numbers? An and statement. Looks like that. So that only occurs when we have log and when we have less than a number. If that had said x is greater than 100, it wouldn't matter. only because it says less than. All right, how about this next one, number 9? I have e to the x less than 2. What do we do to both sides? We do ln of the entire side. We do ln of e to the x less than ln of 2. We do an ln to the entire side. That cancels. X is less than ln 2. I'm going to find out what ln 2 is.
On your calculator.
Type ln 2 in your calculator. Now let me get. Brown, what did you get? Perfect. 0.693. So x is less than 0.693. Maybe after her charges for a few minutes, you can charge one too. All right, how about the next one? What are we going to do to both sides so we can get the variable out of the x? Log base 10, which is just log, right? Going to, I didn't really leave myself enough space. You guys probably have plenty of space, right? No? Oh, sorry. So we're going to do log base 10 to both sides. So we're going to do log base 10 of 10 to the 2x minus 6 greater than log 3. So you do log both sides. The biggest thing that I see when I'm helping people is we're not doing the same thing to both sides. That's like the biggest mistake I see. I'm going to make sure we do the same thing to both sides. We get 2x minus 6 equals log 3. Now you have to solve for x. So what should we do? I said equals. Please correct me on that. Greater than. What should we do? Do I have to yet? Okay, so what am I going to do to get x by itself? You're going to add 6. So am I. I'm going to add 6 too. So I'm going to add 6, and then after I add 6, divide by 2. Now try typing it in your calculator to make sure that you get the exact same answer that I get. I hear the magic word happening out there. Make sure you do those parentheses. Yes. Did you get it? Is that where you go? Yeah. 3.239. Oops, 3.2. 3.2. Okay, do I need another, do I need like x is greater than 0? This is a log. Do I need x is greater than 0?
No.
It's not log, it's not even log. The original doesn't have log. Never mind, I lied. Next one has log. Next one has log. Okay, number 11. What do we need to do first? Actually, I'm going to subtract the 9 first, because the plus 9, the x plus 9, that's not in parentheses with the log, so the 9 is actually separate from the log. So I'm going to get rid of the 9 first. So when I do the 10 base, that would not put 9. Like it wouldn't. I'm not explaining very well. We need the 9 gone first. So my next step is to cancel out log, and log is canceled. That's totally what I meant to write. Sorry. Now it's blue. All right. Take that again. Now we have log, so we need to have 10 to the on both sides. So when you write it, the entire side goes to the exponent. So we have 10 to the log x less than 10 to the 36. Don't type that in your calculator.
Oh my God.
Yeah, don't type it in your calculator. It has like, I don't know, like 36 zeros.
It's 1 with 36 zeros.
That would be, the zeros are always separated in threes. So that'd be like 12 sets of threes. What is that? Okay. All right, so I would suggest if it is like ridiculously large, we'll just leave it 10 to the 36. Is that our answer?
No.
It's not. Because x has to be greater than 0. And this says x is less than that number, but we have to say, nope, it also has to be greater than 0. Remember, that only happens when it's log. Look where I got it in this log. Okay, the last one. 2 ln x minus 1 greater than 4. What should I do first? Just move all that over. Okay, I'm sorry. Add 1, yeah. Add 1. So 2 ln x greater than 5. What should I do? What should I do? Divide by 2. So ln x greater than 5 halves. How do I get x? How do I get rid of ln? Okay, but if you're doing e, that is a base. So we have to do e to the entire side. So e to the ln x greater than e to the 5 halves. So those become exponents when you're doing the base. Those become exponents. And then that's going to cancel out e ln x. Look at x. Greater than, and then that you can type in your calculator. This original question had an ln, which is the same as a log. So I know x has to be greater than 0. This is right. So in this answer, do I have to worry about the x is greater than 0 part? No, because that says greater than 12.82, so we don't need to worry about that part. All right. You got like 6 questions for your assignment, and you got about 10 minutes to work on it. And then we're gonna do that. Oh. Grab a computer if you haven't. Right now is work on this assignment. Now go back and finish other homework. All right. Let's work on this assignment, right? This assignment. It says 6-6 day 2. 6-6 day 2.
This one is ready. This one is left out.
review something that we learned a long time ago and add on to it just a little bit. Quite a while ago, last semester, we took data and classified what kind of graph it would be. And we had options like linear, quadratic,
Cubic.
there's cubic. I don't know if we ever did the cubic one, so quartic. So I'm going to review how we figured out by looking at the data what kind of graph it would make. Back in the day, last semester, we would look at the x's and notice that they were all evenly spaced. So we only looked at our y values. And we said from this y value to that y value, what did we add? Or what's the common difference from here to here? We added 0.5. And then from 1 to 2, we added 1. And then from 2 to 4, we added 2. And then we added 4. We added
60.
Okay. If this was linear, which this is not, if it was linear, the first finite differences, which is what we just did, that's what they're called, the first finite differences would be constant, would be the same number, if it was linear.
But it's not.
But this one's not. But another one might be, so that's why we just jotted down some notes. We have done this before. Now, when it was not linear, we said, okay, well, let's take a second set of differences called second finite differences. So from 0.5 to 1, I would add 0.5. And then from 1 to 2, I would add 1. And then from 2 to 4, I would add 2. And then 4 to 8, I would add 4. And then I would add 8. So that's not constant either. But if it was quadratic, let's spell that wrong. The second finite differences would be constant. But this one's not, so I know it's not quadratic. So then what should we do? Should we do it a third time? Because if 3 of them work, then it would be cubic. Or if 4 constant differences work, it would be quartic. What's going to happen if I do it a third time? Do you see these numbers are like not getting anywhere? I'm just going to keep doing the same thing over and over again. So the problem is it's not adding the same number each time. Look carefully at these numbers. Maybe look at 1 to 2, 2 to 4, 4 to 8. It's not adding the same number. It's multiplying. You see if I do a half times 2 or 1 times 2 or 2 times 2, 4 times 2. Do you see this is not actually adding? So this makes this exponential. When we're multiplying by the same number each time, it's exponential. So we're multiplying by the same number. We're going to call that called the common ratio. It is exponential. Exponential. We're multiplying by the same number each time. That's exponential. So you kind of have to goof around with these to figure it out. So I have 3 examples, more examples that I want you to try. Example B, and then when you turn the page, there's 2 on the next page. We need to figure out what kind of function make these numbers. linear, quadratic, cubic, exponential. So you try them. We'll look around. So for this first one, a lot of you started out by doing adding, subtracting, plus 2, plus 6, plus 10, plus 14. And that wasn't constant, so we tried a second one. I'll get there. So when it's constant after the second finite difference, we say this is quadratic. And then this one, we are subtracting 3 each time. It's okay if we're subtracting instead of adding. It's still constant. It's doing this exact same thing, so this is linear. All right, this is the one a lot of you just had questions about. A lot of you were like, oh, this is divide by 3. Divide by 3. Divide by 3. But Ms. Criswell didn't give us a division thing. So instead of dividing by a number, multiply by its reciprocal. And now we're multiplying each time by the same number, so this is exponential. Okay? The next part is we are going to take 2 points that we know are exponential and we're going to write the equation from 2 points. So the equation of an exponential function is y equals a times b to the x. Y equals a times b to the x. And in previous lessons, we've learned kind of what that A spot is. Like when we deposit money, A is the amount that we had at the start. Or if we have like exponential decay, A is like the amount of germs to start, whatever's decaying. And then B is the factor, that's the growth factor, or the decay factor. So we have to find what A and B are, and all we know are 2 ordered pairs. So what we're going to do is we're going to set up 2 equations. We're going to put both of those ordered pairs in to make 2 equations. So I'm going to start with 1/6. And I'm going to write 6 equals A times B to the first. And I'm going to use my other ordered pair, 354. And I'm going to write 54 equals A times B to the third. So I put in my X and my Y. Anytime that you have 2 equations with 2 variables, 2 equations with 2 variables, you solve a system of equations. And you have different ways you could do that. We are today going to do that by substitution. Remember doing this a long time ago. Do you remember doing systems of equations a long time ago? We had to do it with 3 equations and 3 variables also. That was your favorite, I know, I've heard. Don't worry, you'll see it again next year. Here, we're going to solve one of the equations for one of the variables, and I'm always going to choose which one looks a lot easier, and every time it's A. A is way easier to solve for. So I'm going to solve this for A. I'm going to get A equals, how do I solve that for A? How do we get A by itself? Divide by B. So I get A by itself. So I'll have 6 divided by B. You may want to over-exaggerate your shape of your 6 and your B because they look the same if you don't. And then you get really confused. They do. It's super annoying. All right. Now what we're going to do is we're going to take A equals this. That's what A equals. And we're going to substitute it for A in the other equation. So I'm going to have 54 equals 6 over b. And I'm going to multiply that by b to the third. So I substitute it. And then we're going to solve this equation, because once you substitute, you only have b left, and we can solve for b. So I'm going to have 54 equals, right here, b cubed is over 1, and I multiply straight across, and I get 6b to the third divided by b. And then we reviewed exponent rules. What do you do when you're dividing? You subtract their exponents. So we have 54 equals 6b squared. And then we have to divide both sides by 6. We get 9 equals b squared. So b has to be, well really it's plus minus 3, but we will not be getting any negatives for these today. So we're just going to reject the negative and use only the positive. All right, what's I have? B equals 3, yes?
What if I were to multiply the 6 equals 80 first by 9, and then just set them equal to each other?
You will still, it only works if they're both equal to like the same letter. It doesn't work if they're both equal to the same number. Like if you did that, you'd still have a's and b's on both sides. So you'd still have to solve one of them for one of the variables and substitute it into the other. So my goal when I substituted this is to make it so I only have one variable. Do you understand what I'm saying? When you set them both equal to 54, you have both variables. All right, so now we're going to take that b equals 3 and we're going to plug it back in. In a previous equation, it doesn't matter if you use this one or this one or this one. You got to plug it back into one that has a's and b's in it. B equals 3, I'm going to put it right here. I'm going to have 6 over 3 equals a. So a has to equal 2. Once we know a and b, you have the equation. Y equals a multiplied by b to the x. That's the equation. Okay. Now, because we have an exponent on the 3, and exponents always happen before multiplication, but I don't know what x is, so I can't do that before multiplying. So order of operations says no, you have to have that separate. Thank you for asking that. All right, let's try the next one. And this is not enough space for me to put it all on here, so I'm going to put these on separate pages, but you guys should have enough room if you write small enough. I just can't write really small with this marker. So 212 and 324. So we're going to start out by writing 2 equations. And remember, the equation we are using is y equals a times b to the x. So we'll have 12 equals a times b to the second. And 24 equals a times b to the third. And then you have to solve one of those equations for one of those variables. Make it easier on yourself, solve it for a. But it's totally up to you. But I would solve for a. I'll solve this one for a. A equals 12 over b squared. So once you have what a equals, put it in for a in the other equation. Substitute. (24) equals 12 over b squared times b to the third. So I'm going to multiply those together. I'm going to get 12b to the third over b squared. And what happens to my b to the third over my b squared? Subtract the exponents. So we get 24 equals 12b. So divide by 12, and b is 2.
Why don't you multiply b squared by b?
Because this is over 1, and we multiply straight across. All right, I know b is 2. I'm going to substitute that back in. I'm going to do 12 over 2 squared is a. So 12 over 4. So a is 3. And then we write our equation once we have a and b. Y equals a times b to the x. Okay, I've got 2 that I want you to try. Maybe you've already worked ahead. I have 2 of them that I want you to try.
Oh yeah, we do.
When you guys write these answers, let's see, this one is y equals half 4 to the x, and y equals 64 half to the x. I was telling a lot of you to put those parentheses in. You know why?
Why?
You need to say that the x goes to the top and the bottom of that fraction. So you need the parentheses there to correctly state that the x goes to the entire fraction, not just the number at the top. So if you don't have those parentheses in, add them in, otherwise it's not technically correct. All right, the last thing that we are doing is a review on how to do stats and find equations on our calculator. So if you have your graphing calculator, take it out. If you do not, you better find a friend. You darn quick. And if you need to sit and do it while it's plugged in, that's fine too. So we are going to enter in the data. It's in your packet. I can't have it up here at the same time as my calculator. So we're going to enter in the data. Just to remember, how do we enter in the data? We go to the stat button. Stat. And then we're going to edit. And then you're going to type in your list 1 and your list 2 as your X's and your Y's. So go fill out that. At any point where I am not walking around, I can't see if your calculator's not working, you got to tell me so I can get it fixed immediately so you don't get further behind. If you don't have your calculator today, find a friend. Yes, miss. Oh, you don't have your We will together. I was going to go over how to do that again. Okay, after we type in our list 1 and our list 2, we're going to set up a window so that we can accurately graph them.
What I did was,
Go to window. If you have anything in your y equals right now, get that cleared out. If you have anything in your y equals, get that cleared out. I'm going to go to my window, and I'm going to choose x's that make sense for the data. Look at my data, and the x's go from like 1 to 7, so I chose 0 to 10. And then I look at my y's, and they go from 12 to 96, so I chose 0 to 100. You want to choose a window that makes sense for your data. How did I get to window?
Press the window button.
Okay, just checking.
Windows.
Before you graph, if you go to y equals, make sure there is nothing in y equals. Before you graph, you have to turn on the scatter plot. So right now you can see at the top my scatter plot is on. But to go and adjust what the scatter plot does, you do second y equals. Second y equals is your scatter plot stuff. And you hit enter.